We live inside a mirage called now. Our brains tell us the world is unfolding, second by second, a stream of moments flowing forward. But now doesn't really exist. By the time light from your screen reaches your eyes, it's already in the past. The sound of your heartbeat is history by the time you feel it. We live not in the present, but in a delay, always chasing the world that just happened. Our minds smooth the gaps, turning millions of tiny electrical delays into one continuous illusion, time flowing, moments connected. And so we built our lives around that illusion. We measure it, worship it, fear it. We celebrate birthdays, track hours, mourn deadlines, as if time were a thing we could hold. But time isn't a thing. It's an operation, a calculation the universe performs as it changes. Every tick of a clock, every heartbeat, every supernova is just reality updating its code. And one day, when there's nothing left to compute, the code will stop. In the beginning, there was no before. There was only the Big Bang, an eruption of space, time, and possibility from a single point smaller than imagination. During the Planck era, everything we know of physics was meaningless. There were no atoms, no light, no time as we understand it. Space boiled like quantum foam. Particles flashed in and out of existence faster than any clock could record. Then, something extraordinary happened. The universe cooled, just enough for laws to emerge. Gravity separated from the other forces. Matter and energy became distinct. Symmetry broke. And when symmetry broke, time began. Because only when there's a difference, a before and an after, can change exist, and change is the heartbeat of time. Every interaction since that first second has been a computation. Not metaphorically, literally. In quantum physics, every event converts information, one state of the universe transforming into another. Every atom that collides, every photon that scatters, updates the cosmic database. This isn't speculation, it's physics. The laws of thermodynamics say information can't be destroyed, only rearranged. Landauer's principle tells us that erasing even a single bit of information releases heat, meaning computation and energy are inseparable. In other words, to think is to burn. And the universe has been burning since the beginning. Stars are processes, nuclear engines turning hydrogen into light, spreading energy, writing data into space. Galaxies are networks, billions of nodes trading photons, matter, and momentum. And black holes, they're the ultimate hard drives, storing the information of everything they swallow on their event horizons. From quarks to quasars, the universe isn't just expanding, it's processing. Every second is another instruction executed in the grand simulation of physics. Eventually, computation reached consciousness. Life, a local reversal of entropy, learned to preserve information across generations. DNA became the first storage device. Neurons became the first processes capable of abstract thought. We are the universe debugging itself, patches of stardust that learn to model the code around them. Every thought you have, every memory, every dream, is energy converting into information and then fading again into entropy. When you remember someone you've lost, the pattern of neurons firing in your brain is the same physical principle that drives galaxies to spin and die. Information transforming, briefly, before dissolving. You and I are temporary computations, but so is everything else. The second law of thermodynamics says that entropy, the measure of disorder, always increases. That's why broken glass doesn't reassemble. Why you can scramble an egg, but never unscramble it. Why every clock ticks forward. Entropy gives time its direction. It is the invisible arrow behind every story, every decay, every death. But entropy isn't evil. It's the reason complexity exists at all. Because only in a universe out of equilibrium can work be done, can patterns form, evolve, and think. The same process that ensures the universe will end also made it beautiful in the first place. Order exists because disorder is inevitable. The cost of creation is decay. Humanity has always tried to capture time. We built sundials and hourglasses, then atomic clocks that count vibrations in cesium atoms, billions of times per second. We synchronized cities, markets, satellites. We turned time into the currency of civilization. But the more precisely we measured it, the less we understood it. Every clock runs at a different rate depending on its speed and gravity. time flows slower near Earth's surface than in orbit, and astronauts literally age more slowly. Einstein showed us that time is elastic, stretched and squeezed by energy. There is no universal now, only local computations, each running at its own pace. To the cosmos, time is relative. But to us, finite creatures trapped in the illusion of sequence, time is everything. We invented calendars to make meaning out of impermanence. We fear endings because our biology can't comprehend infinity. Yet the truth is, the clocks we build are not measuring time itself. They're measuring change. And one day, there will be none left to measure. The universe is expanding, not slowly, but accelerating. Galaxies drift farther apart. Cosmic horizons stretch faster than light can bridge them. In 1 trillion years, observers in a distant galaxy will see nothing beyond their own. The sky will go dark, not because stars vanish, but because their light can no longer reach across the growing void. Then the stars themselves will fade. Hydrogen exhausted, they'll collapse into white dwarfs, embers cooling over quadrillions of years. Even they will dim, turning into black dwarfs, invisible, cold remnants of fusion. Matter will still exist, but inert, frozen potential. The cosmos will be a cemetery of atoms. As stars die, gravity takes over. Massive remnants collapse into black holes, the densest objects in existence. They devour everything that strays too close, locking information on their event horizons. For a long time, scientists thought nothing could escape them. Then Stephen Hawking proved otherwise. Black holes evaporate, not through magic, but through quantum mechanics. Particles near the event horizon appear in pairs. One falls in, the other escapes. Over unimaginable timescales, black holes leak their mass back into the universe as faint radiation. It's the ultimate irony. The universe's strongest prisons eventually set their captives free. But when the last black hole evaporates, there will be no captives left. Just radiation, spread thin across a frozen, empty cosmos. No motion, no computation, no time. The heat death isn't fire. It's equilibrium. When everything reaches the same temperature, when energy can no longer flow. In that stillness, there's nothing left to do. Entropy reaches its maximum. The universe becomes uniform, perfectly balanced, and therefore perfectly dead. If the universe is a computer, this is when the processor halts, every calculation done, every file closed. There will be no witnesses, because witness requires difference, energy moving through matter, one neuron firing and another not. When everything is the same, even perception is impossible. Time ends not because it runs out, but because there's nothing left to change. But some physicists argue time might not exist at all. Einstein's equations don't require it. They describe a universe where past, present, and future coexist, like frames of a film. We experience motion only because consciousness moves frame by frame. In this view, the end of time has already happened, we just haven't reached that page yet. All of history, from the birth of the first atom to the last whisper of heat, already exists within the same block of spacetime. So when the computation stops, it doesn't erase what came before. It merely completes it. Every moment, every memory, every spark of awareness remains embedded forever in the geometry of the cosmos. We never truly die, because death itself is part of the structure of time. And here we are, fragments of that geometry, able to reflect upon our own impermanence. In the grand ledger of the universe, our lives are almost weightless. Yet somehow, within that fleeting instant, we've built meaning. We've written poetry, split the atom, mapped the stars, and dared to imagine the end of all things. No other species we know of has looked into the abyss and described it in detail. We not only compute, we contemplate. Maybe that's the point. Maybe the purpose of consciousness is to witness the process, to experience time before it disappears. We are the brief interval between stillness and stillness, the flicker of awareness before the screen fades to black. It's a haunting question. If time gives meaning to life, to progress, to memory, what happens when it ends? Maybe meaning was never about duration. Maybe it was about pattern, about what emerges in the tension between chaos and order. The universe doesn't mourn the stars that die. Their death is what makes new ones possible. Likewise, the end of time isn't failure, it's fulfillment. The equation has run its course. every variable resolved. Perhaps eternity isn't endless existence. Perhaps it's a moment so complete, it no longer needs to move. Still, some theories whisper of rebirth, that quantum fluctuations in the vacuum could spark new universes, that entropy itself could reset a cosmic reboot. In that sense, every universe might be a thought in the mind of something greater, a vast computation running experiment after experiment, each a new timeline. Maybe time doesn't end. Maybe it loops. Or maybe it dissolves into something we can't conceive, a dimension where computation isn't needed, because truth simply is. If the universe is a program, perhaps the end of time is when the system wakes up, when the code realizes it's being read. Picture the last moment before silence. Every atom stretched across unimaginable distance. Every star long gone. The final photon, the last flicker of computation, drifting through a universe too large to notice. It travels for an eternity that no one counts, carrying the last information ever to exist. Then it fades, and in that instant, the exact instant before total stillness, all of history exists simultaneously. The Big Bang, the stars, the people who wondered what it all meant, every computation ever made. That frozen moment is eternity, not endless time, but timeless completeness. The universe isn't gone, it's finished. When the universe stops computing, there will be no one left to ask what comes next. But we can ask now, what if the point of existence was never to last, but to be understood before it ends? What if awareness is the universe's final act of self-recognition? When time dies, memory remains. Not in neurons, not in stone, but in the very structure of spacetime, where every second that ever was still is. So maybe the end of time isn't the end at all. Maybe it's the moment when the universe finally understands itself, and, having nothing left to learn, rests. Every computation ends not in error, but in silence, and perhaps that silence is peace.